Alright, so this is just meant to pick up where we left off. We started with just basic functions and plots. Now I want to add to that using this idea, this object that's called a list, and then creating these list objects using loops. So this is basically the analogous to a sequence that you would generate by hand. But a lot of times, as we're going to see, we want to automate any kind of like repetitious example. We'll be asked a lot of times to do things a very large number of times. So we want to automate that process, and a loop is something that allows us to do that and farm our computations out to the machine here. To begin, we want to understand this kind of thing called a list, and it's basically a collection of objects. In Python, we write it with square brackets, and we oftentimes will have these saved as variables. So for example, if I have a equals 1, comma 2, comma 3, then this thing a is the list 1, 2, 3. These things in the list, these elements of the list, have indices. In other words, this is the first thing in the list, this is the second, this is the third, right? Because they don't necessarily have to be ordered things. I could change my list to be 1, 3, 7, 3, right? And just because this is the fourth thing in the list doesn't mean it's the fourth highest thing in the list. So to refer to these, we have to use the indices. The funny thing about indices in Python is that they start at 0. That may take some getting used to. The way that we call a specific element of a list is using the square brackets called on that variable, like this thing a is the list, and I'm looking for the first thing in that list. Similarly, I can get the last thing out of it with a -1. If I want more than one thing, I can use the parentheses. So this will start and give me everything through the third index, which is really 0, 1, 2, 3. So everything up until 3. All right, so that's enough for a list. Then I can do things to the list. Instead of referencing things, I can add onto it. So if I wanted to add another guy on here, I could say a.append, and maybe I'll tack 5 on, and now if I look at a, it's got 5 on the end. So a lot of times what we're going to do is we're going to start with some number, do something to it, and want to have that do like the result here, because maybe then we'll do something with the result of it. So a lot of time to start with some number, we could create our, let's rename our list a equals 1. All right. Now, if I wanted to create the next integer to this, I could say, that's the first element in that list plus 1, right? So maybe I want to append a 0 plus 1. Okay, and now if I look at a, great, so maybe I want to actually create a list of the first 10 integers. Well, rather than doing this 10 times, it would just be that I change this by 1 every time through. And that's a very common thing to do on the computer. So we have something like, we have these counters that will tick through these values for us. And repeating that operation while it kind of goes 0, then 1, then 2, then 3 is exactly what the for loop does for us. So quickly together in one example, we have for num in range 4, let's just print the number. And you see what happens here. We have range 4. Again, we're starting to count at 0. Goes through once, it prints 0. It goes through again, it prints 1, then 2, then 3, and then we're done, because that's all of the things that are in range 4. So this is how we can create lists. Returning to this example, if we start with a list that just has 1, and say for num in range 9, right, a.append a of num plus 1. And now we look at A. There we go. We've got our first 10 integers. And we can do anything that we want to this thing. If instead of adding 1, we wanted to add 2, and that would just give us the first odd integers, you know. We could multiply it by 2. We could square it every time. That's not very interesting. And subsequently, we can just use what we did before to plot the results. And now, usually, we're going to be interested in is actually just plotting this list, because the x coordinates are actually the indices, which is the default behavior for matplotlib. But rather than looking at it as a smooth line, we want to look at it as points in a sequence. So we'll often just use this little circle O, which gives makes the markers the point values, and then everything else holds true. So I think that it's good practice to just play through with a bunch of different things that you can do to numbers, you know, create all sorts of different relationships and look at the plots of them as a way to get used to using these for loops and this list object.